Hello, I'm Ethan Fry, and welcome to the second episode of Weave SDK Overview. In this section, we will look at transaction flow, how a transaction is processed in our system. To work about this, we first need to go through a number of interfaces which are defined. These interfaces were implemented in different ways by different modules and different applications even. But these are the core aspects of the Weave framework. The first one is persistence. Every object is sent over the wire, like transactions and messages, as well as things are stored in the database, models must be called persistent. Persistent includes a marshal and unmarshal methods, meaning it can read and write to binary data. You can use any codec you want, in fact, but all the standard Weave modules we use the protobuf codec. The GoGo protobuf will generate these marshal unmarshal methods for you. You can also have marshal unmarshal call GoAmino or use JSON encodings if you want to. So every module can actually have a different decoding if it wants to have those. But remember, so everything, the persistent word means it can marshal and unmarshal itself. And notice these are not marshal binary, marshal JSON, they're just marshal, so it knows an encoding for itself. So the next thing we have is transaction. Transaction basically is an envelope. There is a user-defined message at the base of it, but we want to wrap that with other information. These other information, which are basically we call, which are wrap envelopes. It wraps information. So a transaction just has a get message command, and it's persistent. But then you have lots of other types. So when decorators handle a transaction, they often check to see, does it implement the fee transaction interface, for example? Does it have this function feature get fees? Does it implement the signed transaction interface, or multi-sig transaction, or any other transaction type you want to have? So you can have these extra interfaces which you add on to it. Therefore, an app-specific transaction may implement multiple interfaces beyond the basic transaction interface, allowing the use of different decorators. So as you said, the envelope there, which is extensible, has in the base of itself, it contains a message. The message is what the user wants to execute. All the fee payment and signatures wrapped around it are just a means to the end. The end is, I want to vote on this proposal. The fees I have to pay, the signature I have to make, but those are basically an envelope to make the blockchain happy and authenticate myself. And in the end, the message is actually my intent, user intent. A message, again, is persistent. And it has two main functions, path and validate. Path is used to route it. Rather than use reflection everywhere, use some type magic lookup, which I had done in a previous version. We explicitly have a function on every message which returns a string identifier, unique string identifier for itself. It can be anything you want, and generally should be hard-coded per type. And then that can be fed in a map to a handler. A router can use that to route it. It also should be able to validate itself. Validate will check for internal consistency of the message, whether the fields make sense, if there should be, if there are fields missing, if addresses are not 20 bytes long, it can throw an error. If you send messages with negative amounts or missing token tickers, you can throw messages. Validate does not have access to the database or any external information. So it cannot check whether the account has balance. It just checks basically if this message is sensible within limits. If you have a text field, you can say it has to be under 500 characters. So someone can't put megabytes of text in there. This is essential to prevent a lot of abusage. You check in the validate method, and then the handler can be much simpler because it doesn't have to worry. It knows that this message has legal values. Once the message has been processed, and all the envelopes have executed, basically the final thing we have is a handler which actually processes it. So I'll explain decorators later, which are done to process the transaction envelope, but the handler basically is a check and deliver message. These get context, which contains the block information, the height, time, as well as signature information, authentication information, who has signed it already, which is set by the decorators. It also contains a store, a KV store, which is able to read and write database, which we get into later, and the transaction itself. It returns a result or an error. So we want to separate those results: a result on success or an error on failure. We have a separate call for check and deliver to allow them to take shortcuts. I think we ended up doing very similar code to most of these, so we may want to combine these to one in the new future version. But right now they're two different ones which reuse validation code and do similar logic. We will look into that later. But handles check and deliver, you can imagine them the same for now, more or less. And you are past a full transaction here, so we can have a same interface for kind of decorators, fulfill handler. But really, if you're building a handler, you should only worry about tx get message. A decorator is actually before the handlers. So the whole framework, which we'll see piece by piece here, is the transaction is parsed by the decoder, is persisting unmarshal it, and then we run a chain of decorators. So many decorators are passed, and then it is sent to a router which handles it, sends it to handler, and runs it. This is important for all checks like fees or signatures, logging, checkpoints, or various objects. You see the decorator looks like a handler, except it has one more argument in the check and deliver calls. That is the next handler. So it can process something, and a decorator may do some actions itself, but in general it will do some pre-processing, then it'll call the next handler, and then it'll make some post-processing. So that's a decorator. It wraps it. The typical word in web applications is middleware, and this basically is a middleware, the same idea. As we were discussing this, the word decorator is more programmatic, like in Python decorator, or even in modern JavaScript ES7, I think you have decorators now, or in Java. So the idea of a decorator which wraps a function, adding functionality to it, and this basically just wraps a handler. You have a series of decorators around one handler. A decorator stack can do almost anything that the Cosmos SDK BaseApp RunTX does, but it's very flexible. So you can construct a series of decorators, a series of actions to run, which is extremely flexible, and don't have hard-coded logic. So every app can have different stacks, while making use of the same basic functionalities, same modules. After the final decorator stack is handled, we have to route these messages to the proper location. So we use the message passed as a key. You see, routes basically stores as a map from a string to a handler. When you handle it, when you register it, you call handle, and you give a message and a handler, and we then store it on the message path. When the router itself implements the handler interface as well, you see that. So when you call deliver on the router, it will then take the TX message, look to see what the string is for it, look up in the routes to see if there's a handler. It will return an error if there's no handler, and if there is a handler, it will then just call the handler with that message, that transaction. Notice that the router also implements a handler interface. Everything implements handler interface, so we can construct a nice series of things in here. And theoretically, these handlers that are stored in the router could also be decorator stacks, again, that have a series of decorators, then another handler below it. So having everything implement the handler interface allows a very, very flexible design. How to use this stuff. So once I've described the design, we get a little more concrete here. When you want to construct an application, this would be not in one module, but in your application, your custom application logic. So your guide D logic, or your regen ledger logic, or any sort of IOV BNSD logic. Any sort of application you build on the blockchain would construct a custom app logic. And so to construct your application, you need to construct a series of decorators and a bunch of handlers and register in the router. And this is all the code you need in your application to set this up. So here's an example of a chain of decorators. You notice how flexible this is. So we take a logging decorator, which will actually, we'll look into these details how it works later, but it will basically log at the end of execution whether an error, success, and how long it took. a recovery, which will catch any panics, a key tagger, which will automatically add tags for any keys that were read and written inside the database. A save point is done on check, which says revert all changes at this point. So you notice if there's an error, it will throw it away at that point. If not, it will commit it. Then SIGs. What that does is actually the saying that if you have a failed check, no database changes are written. Then it calls SIG's new decorator, which will verify the signatures and update the nonces. On deliver, this location means that if it fails in deliver, it will abort all changes below the on deliver save point, but the nonce update from the new decorator will not be reverted. Actually, if you see below, there's a new feed decorator below that, which usually you'd probably want to have above the save point. So on a failed deliver attempt, it will update the nonce and deduct the fee. In the current architecture, it updates the nonce but does not deduct the fee. And you see how this can be totally changed very easily without, here is this, the feed decorator, which can be moved above this for most applications, but in this case we don't do it. So you have complete control of the ordering and what the actual effects are. The multi-sig decorator will allow you to add support for multi-sig contracts. The cache feed decorator will deduct the fees and show your account has the fees. Batch new decorator will, at this case, basically take a message, and if it's a batch message that is a series of other messages, it will then execute one time per message below the stack. So a batch message will call next many times. If you have 3 messages in the batch, it will call the lower sequences 3 times down the stack and into the router 3 different times. This note that Cosmos Decay has always a series of messages, a chain of messages. We don't hard code that into the application. We just have one message allowed, and you can then make a batch message which contains multiple messages. And you can also say some messages cannot be in a batch because you control what the batch message contains. So the batch message says that you have to find actually a batch message type in your application to support this. And utils new action tagger says basically tag it with the path of everything that's run. So we basically say you can add and automatically tag it. So rather than every handler having to tag this event, we just automatically add a tag for the messages that are executed. This is after a batch. So if the batch has 3 different messages, a send transaction and release escrow message and a vote, it will then add those 3 tags: send, release escrow, and vote. And the key tagger on top will just write which keys were modified in the database as tags, which you can subscribe to. So you can quickly subscribe to any key that's written, for example, my account balance, or the state of an atomic swap escrow, or a proposal. And every time the proposal state changes, we get notified. So to build the router, we need to take the handlers. So every module that has any handlers should provide a register routes function. And this will then take the routers an argument and any other information it needs to construct these handlers, and then you'll add them to the router. As you saw, the router has a register method, a handle method. So we see here we have a cache controller. I'll talk about more in depth later, but the cache controller effectively is access to moving tokens. It gives you access to move tokens, and this can be swapped out for other implementations. So if you have a different token implementation rather than a standard one, you can use it there. All modules, rather than depending directly on cache and hard-coding that dependency, that if they move tokens at all, it will take the cache controller in there. Basically, you make a router, you register routes for all the modules that you want to enable, and then the router has all the handlers it needs to know about. And once we've built the stack and the router, to build the stack up, to build your application is really trivial. You take that chain of decorators, add with handler on the router, and that creates an actual handler object. So that is able to coalesce it. We actually took a lot of ideas from Negroni, which is nice middleware for Golang web applications. You can look at how they build their chains of middlewares and combine those into handlers. So you can look at that. And look at the chain with handler and the chain stuff. And basically, when you build a new application, you take a store, which is a database store, the TX decoder, which will parse those raw bytes, This handler, which we just show how to create the handler. A ticker, which is an optional ticker, which is called every begin block, and whether or not it's debug. Debug options will allow us to do some things like show full stack traces on errors, for example. That's usually you only show the error message in the log when you return ABCI error, but if you have a debug option flag passed in when you run the application, it will dump the full stack trace. This is great for debugging, either in tests or at local host or some dev machine, but you don't really need whole stack traces dumped out to the user on production machines. So we allow that to be switched on or off in runtime. So yeah, besides when a transaction comes in, the only thing that happens besides the handler, which we just constructed with a series of decorators, and the router, which we control, is TX Decoder. So you have full control there. So if you want to run the handlers for the transaction, check TX, add a decorator. The decorator will simply say on check TX, return OK. And it will then, if it made it to that point, it will just return OK and abort the chain. It will never go down to the handler or the router. You can switch the feed decorator out. For example, we have two feed decorators in Weave. One is static feed decorator, or the new feed decorator, which takes a fixed minimum fee configured in the database from Genesis file, but can be updated later. And the other one, you have a dynamic feed decorator, which allows does a similar thing, but it's more complex because it allows the handler to return a required fee. So you can have product fee. So, for example, one transaction type requires 10 atoms or 10 IOV tokens to register a username, but sending money has just the anti-spam fee. And we can't actually deduct the fee until after execution of the transaction, but then we want to revert all changes if it's not there, so it's a lot more complex. So we have a dynamic feed decorator, which is a much more complex beast. And if you have a different idea of how to deduct fees, you can build another one. You swip out the stack and you have the access. You don't have to fork the whole framework. You can just switch out your thing. You can use one of those two standard ones or build your own feed decorator with your own custom thing. Adding more support for signature algorithms, same thing. Change the decorator. Swap out the signature decorator and with a different decorator. And when we have this completely flexible stack, what's left in BaseApp is very minimal. All that BaseApp does, it registers TX decoder, so you basically load the transaction bytes. So take those raw bytes and parse them and either turn an error, and then you call deliver. B.handler.deliver is a handler stack. That handler is that whole decorator stack and the router and all those registered handlers that you just constructed in the last things. It gets the context, which contains the header information inside of it, the chain ID, and a logger. And it takes a deliver store, which is basically a KV store you can write to, which will be committed at the end of on commit from the ABCI commit thing and the transaction. And if that deliver message, you see this add val change, is if it's successful and you return a result with changes to the validator set, it will store those because those are returned end block. So your every transaction can then just return a change to the validator set. These are coalesced together and stored in the BaseApp. And on end block, it will tell Tendermint these are the changes we wanted for this block. To make our logic computation deliver TX, compute the validator changes, but actually execute it in end block, which is what ABCI requires. It's really simple, and you see how we have full control. You don't have to fork the BaseApp at all. You don't have to override deliver TX at all. You can just pass in a different handler and a parser. So we can switch anything out. We can use JSON. We can use different stacks. We can remove signature validation. We can change fees. We can remove tokens. Anything you want here. Nothing is given. The whole recovery logic, how we handle panics, how we log messages, everything is flexible. Is not given a BaseApp. Is constructed in your application. And notice also that we take an error here. It says error here is return deliver or error. And only at this point does the error coalesce into ABCI error message. I'll get into that more later, but I think it's a very important point for me because we have a full Golang error, including PKG error stack traces and other information we can embed into it up until that point. And once we have gone through the stack, we have full access in the stack, you have full access to all the information. For debugging, it's great. And only when you hit the interface? Do we coalesce that into that ABCI thing, which has an error code, code space, and log? And we lose a lot of information at that point, and that we only do that at the last moment, which is when we hit ABCI interface, which you have to serialize it. Internally, we have a normal Golang error, which again, like with PKJ errors and other information on there, you can embed a lot of information on errors. Thank you for watching. There will be another section which will go more into the details of internals of handlers and decorators, how they function, and some examples to give you a better idea of how you can use decorators to fully customize your application.